Hello, my name is Karen Douglas Collins, and I am a math middle school teacher at Family Cream School. I will be working through some math problems that will help you prepare for the PARCC assessment. I will start off with this problem here, which is an 8th grade standard geometry. It reads, a right circular cone is shown. In the figure, point A, which is here, is the vertex of the cone, and point B lies on the circumference of the base of the cone. Here's point B. The cone has a height 24 units and a diameter of 20 units. I have already labeled both of those. What is the distance from point A to point B? We will be working that through. Okay, I have posted here the formula Pythagorean theorem, and it reads a squared plus b squared equals c squared. Let's work through this together. A squared is your 24 units. So I have 24 squared plus b squared, which is your 20 units. We will be taking half of that. Half of 20 is your 10 squared. And we do not know yet what that c squared is, so we will keep that as is. 24 times 24 will give you 576. 10 to the second power, or 10 squared, is your 100, equals your c squared. If we add both of those together, we will have 676 equals c squared. Take the square root of each side of the equation. We have the square root of 676, along with the right side, the square root of c squared. If we take the square root of 676, that will give us 26, and c squared will undo itself, and now it will become c. So to answer that question, what is the distance from point A to point B? It will give you 26 units. All right, so that is a practice problem that we have just did working with the Pythagorean theorem. Hello everyone, we are now ready for problem 2. We will begin with part A of this particular problem. This is 7th grade standard. This is ratios and proportions. Let's start off. We have a table in front of us. The table has line 1, 2, 3, and 4. For each line it has 2 coordinates, and we can change each coordinate to the value of what is written. So I will be starting off with line 1. I will change that point to the value of 1/3. And I will change the second point or coordinate to 2/3. These two ratios, or these two values, are not equivalent. They are not equivalent because it shows that for every 1, there is 3. We cannot have 2/3 because if you take a look at these, they are not equivalent. If I took 1 times 2, it does equal 2. But if I did the same thing to the denominator, times 2, it does not equal 6. So I will be checking this off as line 1, not a proportional relationship. Line 2, it gives us the points 1 and 2 and 2 and 4. Let's take a look at those two to see whether they are or have a equivalent relationship. 1, 2, or 1/2, does it equal or equivalent to 2/4? If I took a look at that and said 1 times 2 does equal 2, and the denominator, 2 times 2 does equal 4. So yes, line 2 is a proportional relationship. So I will check that off there. Line 3, take a look at that. We had 3, 1 and 6, 2. You're asking yourself, are those 2 points equivalent? If I did the same as I did before, change the points into a value, 3 over 1, 6 over 2. I do the same thing. I take a look at each. If I multiply the numerator by 2, multiply the denominator by 2, 6 over 2, yes. Again, line 3 is a proportional relationship. So I will also check that off. Now, line 4. If you take a look at line 4, it has 0, 2, and 5, 4. I will do the same thing. I will change both points into the value of 0 over 2 and 5 over 4. If you followed through with what we did with line 1, 2, and 3, you will see that line 4 is not a proportional relationship. I will check that off here. Okay? And you will see that if I multiply the numerator and the denominator by 2, it does not show any type of equivalency. All right? So they are not equal or equivalent. Now take a look at line 5. It's showing that it has the point 4, 4, and 5, 5. All right, I will do the same as 1 through 4. I will be writing the value as 4 over 4, and also I will be writing the value 5 over 5. If you took a look at that also, every 4, it will be 4. We look at this a little different. It will continue with, I could also have 1 over 1, 2 over 2, also 6 over 6. So all of these are equivalent proportional relationships. So line 5 is also a proportional relationship. So I will show you a different method of how you can tell what a proportional relationship is when we take a look at lines 1 through 4 by graphing those. All right? Okay, everyone, now we're ready to do a second method. We will be plotting the points so we could tell whether those are considered proportional relationships. Let's start off with line 1. I start with the origin, which is right here. I'm moving to the right 1 and up 3. 1, 2, 3. I plot that point. Second point, I start at the origin. I move over 2 spaces, 1, 2, and I also move up 3. 1, 2, 3. When you take a look at this line that I have just plotted those 2 points, we can tell that this is not a proportional relationship because this line does not pass through this origin, okay? So that is another reason why this is not considered a proportional relationship, okay? Now let's take a look at line 2. Line 2 we will also graph. We're starting at the origin again, and it says 1, 2, we're moving over 1 and up 2, 1, 2. I plot that point. The next point is starting also at the origin, moving over to the right 2 spaces, 1, 2, and we're going up 4. 1, 2, 3, 4. I plot that point. If I continued with this, this line would pass through the origin. So this point or this line 2, yes, it is a proportional relationship. Now let's take a look at line 3. I will be plotting those 2 points, again starting with the origin over 3 places, 1, 2, 3, and I'm going up 1. Again, starting at the origin, it says over 6. I'm moving over 1, 2, 3, 4, 5, 6, and I'm going up 2, 1, 2. If you take a look at those 2 points, they also would fall or pass through this origin. And again, that will let us know that this has a proportional relationship. Now, let's take a look at line 4. Starting at the origin, we do not move at all. We stay. We move up to on the y-axis. We plot this point. Also, beginning at the origin again, we're moving over 5 spaces to the right. 1, 2, 3, 4, 5. Then we are moving up 4 places. 1, 2, 3, 4. When I plot that point, you can see that it does not fall through or pass through the origin. So this is again another way that we can tell the proportional relationship and know this is not a proportional relationship. Now let's look at 5. 5 is containing the point 4, 4. I will start off at the origin, move over 4 spaces to the right. I will be moving up 4 spaces, 2, 3, 4. I plot that point. Looking at the second point, again, starting at the origin, moving over 5 places to the right. 1, 2, 3, 4, 5. Up 5, 1, 2, 3, 4, and 5. Here we go. All right. You also take a look at that. If I continue this line, it will pass through the origin. And yes, this is also a proportional relationship. So there we go. We have 2 ways that I have just shown whether you can tell whether a proportional relationship is going on. 2 methods, one by graphing, that's a quick way, and the other one is changing each point to a value as a fraction to see whether those 2 fractions are equivalent. Let's move on to part B. All right, everyone, now we're ready to explain and to tell whether we can move forward to see whether we can make the correction of changing what is not a proportional relationship to a proportional relationship. If you remember earlier, these 2 points or these 2 values, sets of fractions, actually showed you whether these are proportional relationships. On the board, we have 1 over 3 and 2/3. I will be changing around these 2 fractions, and these 2 I will be able to make them into proportional relationships. I have decided, and there's many ways that you can do this as long as they are equivalent. Instead of 1 over 3 or 1, 2, 3, I will be changing 1 over 3 to 4, 6. I have 2/3 or 2 to 3, which is equivalent to 4 over 6 or 4 to 6. In your head or mentally, you can multiply the numerator by 2. It will give you the 4, and also using that same 2, multiply the denominator by 3, it will give you 6. These 2 ratios are now equivalent, and if I plotted these, you would see that this line would fall through the origin, and that will let you know also that this is a proportional relationship. This particular line that we had earlier, it has 0 to 2 or 0 over 2, and we have 5 to 4 or 5 over 4. I will be changing this also to make it a proportional relationship. Instead of taking the 0 to 2, I again will mentally multiply the numerator and the denominator by 3 this time, or I can multiply it by 2. Looking at the graph, in which I will not be graphing this time, I would change that to 10 over 8. Again, if I plotted these 2 points, these 2 will fall or pass through the origin, and that will also let us know whether these 2 ratios are equivalent. So I would check that off. So I would be writing, I would show I have changed this fraction or ratio to 4 over 6 or 4 to 6. This ratio, along with five fourths to 10 over 8, passes through the origin. I have changed this fractional ratio to 4 or 4 to 6. This ratio, along with 5 over 4, if you can read that, let me clear that a little better. 5 over 4 to 10 over 8, which is equivalent, passes through the origin. So above we have 4 to 6 is equivalent to 2/3, and 5 fourths and 10 eighths are equivalent. Both of these lines, line which is here and line which is there, both of these pass through the origin. So that is describing and showing our work how these 2 lines are proportional relationships. I have changed them to where they are equivalent. All right? Okay, everyone, we are now ready for problem 3. This particular problem is a 7th grade standard speed. All right, in front of you, you see the sample problem, and it's talking about object A, object B, object C, and object D. It's saying that if an object has constant speed, then the speed can be computed by the change in the distance divided by the change in time. Again, we have 4 graphs including tables, and they're shown with objects A through D. Based on the information given, they're asking you to drag, okay, once you find out moving from what is the information that they give you, if you took the distance and divided by the time for each object A and B, which is giving you the graph, and taking a look at the table, object C and object D. You could take any of the points, looking at the time and the distance, any of those on this line, and divide the distance by the distance divided by the time. If you did that looking at object A, you will receive 20. It does not matter. Again, any point from here will still give you the same result. I took, all right, taking a look at object A, I took the time, All right, I moved over 5 spaces to the right. When I moved up, I have 100 with the distance. If I took the distance again divided by the time, I received 20. Take a look at object B. I did the same thing. It does not matter which point that you choose. You should still receive the same. All right, I took starting with the origin, I looked at the time, I moved it over 10 spaces to the right, moved it up again to 100 with the distance. I divided 100 into 100 divided by 10. I received 10. That was object B. Taking a look at the table where it says object C, this time what I did, I took the greatest of the information that they gave us. The time was 9, the distance was 30. When I took the distance and divided it by the time, 30 divided by 9, it gave me 3.33. That's continuous. I stopped after the 2 places. I also again looked at object D. It again has a table for you. With that table, I took the greatest, all right, and I have the time, which is 4.5, the distance, which is 30, 30 divided by 4.5, I received 6.6. Both of these 2 tables, it would be the same. It does not matter which you choose. You will still receive the same result. Once you receive from object A, object B, object C, and D, you then put it in order. They're asking you from greatest to the least. Take a look at your results. If you had to use this on the computer, you would be dragging, all right, each object in the correct order. We will not be doing any dragging, but we can place this in order, and this would be object A. If you look at all 4, is the greatest. So I would put, and I'm just going to abbreviate, object A continues to be the greatest. Object B is next. Taking a look at object C and object D, the next would be object D. And the least amount would be object C, which is 3.33. We have placed these objects, the results of these 4, and we have put them in greatest to least. Again, let me remind you, if you were using the computer, you would be dragging these in order from greatest to least. That is it with practicing PARCC problems. I would like for you also continue to work through the same problems for practice, and also, of course, there are additional problems for you to practice. See your math teachers, and you will be doing a great job with practicing, and I would like to say good luck.